When thinking about cubic functions, it's important that we know that they can be factorized into one of 4 different forms. The simplest form is when it's 3 brackets each of them different. So something like x minus alpha, x minus beta, x minus gamma, and there's an a out the front to show that this could be ax cubed when it's expanded. What that looks like is, if this is the x-axis, it's going to have 3 roots on this cubic at the points alpha, beta, and gamma. There are 3 distinct real roots to this type of cubic. The next type is where one of those brackets is squared. So we get something like x minus alpha squared, x minus beta. Now what that looks like is it still looks a bit like a cubic, but instead of passing through 3 times, that second time turns into one of those times when it just sits on the axis. In this case, that point there is alpha, because that is the repeated root. And this point here is beta, the single root. So we have one single real root and one double or repeated real root. The next one is taking it one step further, which is when that one bracket is to the power of 3. Now that is the type of cubic that doesn't go up and then down again. It's that type of cubic, like x cubed, that sort of has one point and then carries up. It never actually bends all the way down. And that point there in this case is going to be alpha. This is what's called a triple root. And it's a real root as well. Now finally, we might have something like x minus alpha times some quadratic. And what that looks like is it's a cubic that has one root there, but then this bit bends up and never touches the x-axis again. That is at alpha. But there's 2 roots here which don't actually happen. This one has one real root and 2 complex roots. Now, what's important about all this is the nature of those roots. Notice that we can have 3 distinct real roots, we can have repeated roots, or we can indeed have 2 complex roots. Now, we know from the conjugate root theorem that we have to have an even number of complex roots, so there's either 0 or 2 in this case, because there can at most be 3 roots in a cubic because of the fundamental theorem of algebra. Some of those roots might be repeated, as we said. In these cases, we have repeated roots, or they might all be distinct, or there might be 2 complex roots. But these are all the possible options that could happen for a cubic when we attempt to factorize it.